Hey guys, we're up for chapter 11.
Chapter 11, getting near the end.
Skipping around a little bit though.
Yeah.
We went from chapter 8 to chapter 11. And again, it's based really just on priority of what we need to finish before the end of the semester and before testing. So we got to get to this.
Yep.
And this is typically what people think of as geometry.
Right.
But yet every book puts it at the end of the book.
Right. And this should be, the good news is you guys are familiar with most of these formulas. You've seen them before. And so, but really this is just kind of to get you guys more into volume and surface area and things like that, is to kind of go through the two-dimensional first. So.
Right.
But well, let's just get to it, I guess.
Yeah.
So. Anyway, so the first four we're going to look at, guys, are the area of a square, area of a rectangle, area of a parallelogram, and then area of a triangle. Now, I know that last chapter we talked about a square, a rectangle, and a parallelogram kind of all being interrelated, but the formulas are different in some aspects, or the understanding behind the formulas are different in some aspects. Big thing to remember here is, as you see with the asterisk, is up there it says the base and the height must be a perpendicular. This is specifically important for your parallelogram and your triangle. I mean, it's or any trapezoid when we get there. Those, you got to remember those things there, that where the base and the height are, it must be perpendicular to one another. With a rectangle and a square, you know, that's easy to see because where the corners are at is you have a perpendicular. So.
Right. We don't want to make too big of a jump here, too. What we're talking about here is finding the area.
Oh yeah, area
of a specific shape. And as Mr. Bedell said, you've seen this before, but we just want to make sure you understand what that means. We're trying to find the area inside of a shape, and that area is measured in square units.
Right.
It's how many square inches, square feet, square miles, whatever we happen to be talking about, fit inside of the particular object that we're talking about. And so we have formulas, really, for each one of those, and we just need to be able to plug into a formula and use the formula.
Yeah, figure out the right dimensions and go to work.
Yeah.
So, you know, area of a square is just side squared, or you can also consider area of a square just the length times the width, but you know, we always think of it as side squared because all four sides are the same. So if you just take one of those sides and you square it, you can find the area of a square. Theorem 11.1 is the area of a rectangle, which is just base times height. Now the area of a parallelogram, this is the one where you got to remember that rule of where the base and the height meet must be perpendicular, is that the area of a parallelogram is still base times height like a rectangle, except the perpendicular is either outside the shape or inside the shape. You got to kind of draw an altitude in there, and that way you can find your height. So be careful here.
Yeah, just don't use the other side of the parallelogram
Right.
because it's not at a perpendicular. It's at some weird angle, and so it doesn't apply to the area.
Right.
It has to be a perpendicular height.
We'll look at an example of that one here in a moment. And then the area of a triangle is 1/2 the base times height. We've had some experience with this back in the previous chapter before this, when we were doing our trigonometry, where you had to find the height and then go back and find the area. So you have some familiarity with this.
Yeah.
Just remember, once again, unless it's a right triangle, you're going to have to draw in an altitude to make a height for a triangle.
Just think of a triangle as half of a rectangle.
There you go.
And so it's half of the formula.
Yep.
So
Easy enough. All right, here's some examples. So here's the parallelogram, because typically this is one of the ones that's tougher. And as you can see, they've drawn in two different heights that you could use. You could use the height of 4 inside the shape. Notice there's a perpendicular right there between the two parallel bases of that. Or you could draw one from the outside where RU is. They draw that one in, make a perpendicular with the PS side on the bottom, and you can have a height of 8 there. And so either one of those, whether you make it inside or you make it outside, it's up to you. Typically when I do it, I usually visualize that 8 on the outside when I do this. I don't know if you like to look from the inside.
typically I go inside, but again, all that matters is you make sure you pay attention to what base that height is perpendicular to.
That's true.
So,
and we don't necessarily care how far the distance is from P all the way to U, guys. We're only concerned with from P to S, and then basically that vertical height from R down to U, which if you slid that over, it would be from R down to S, kind of the idea here, you know?
Right, we're only finding the area of the blue part.
Yeah.
Yeah.
So if you go ahead and do this, I mean, there's two different ways you could do it. Perimeter, guys, remember, is the distance around. And so remember that on a parallelogram, opposite sides are congruent. So if PQ is 12, then RS is also 12. And if PS is 6, then QR is also 6. 12 and 12 is 24. 6 and 6 is 12, and 12 plus 24 is 36. So you get a perimeter of 36. Notice they didn't use the 8 because the 8 isn't a side of the parallelogram. It's just the height. But then when you go to find the area, there's two different ways you could do this. You could use the height on the inside, 4, which makes a perpendicular with the 12. 4 times 12 is 48. Or you could use 6, that's perpendicular with the 8, of RU, so then 6 times 8 is also 48. Now, one thing here that in the PowerPoint it doesn't have in there, if we were to just give this a label, a unit measure, if they don't give you a measure guide, we would say that the perimeter is 36 units and that the area was 48 units squared. So we write the word units and then put a square after that word units to show that it's area.
Right.
You know, if somebody's looking at this and they want to know what those numbers represent without seeing the A or the P, they could look at the units and the way the units are set up, and you would know that it's perimeter or area. And if it was volume, it'd be cubed, it'd be units cubed. So
Yeah. I don't know in the past for you, but I'm kind of a stickler for that.
me too. I mark things wrong if that's not
You need to
right.
have the units
Yes.
on there, because I want you to tell me that you know that area is measured in square units.
That's right.
Yeah.
You got to know that stuff, guys. All right, so then we have a triangle. Now, to find the perimeter of the triangle, guys, hey, chapter 7 comes back to get you here, where you can't find the perimeter of this without either understanding Pythagorean triples or understanding how to do the Pythagorean theorem. So to do the perimeter of this, you've got to know that that's a 5, 12, 13 Pythagorean triple, or you've got to do a squared or c squared minus b squared equals a squared to figure out that that third side is 12. So, I just use Pythagorean triple, but when in doubt, you got to use Pythagorean theorem to figure that out. You can't use trig here. You don't know any of the angles, so that's all you really have. So the perimeter of this triangle is, 25 is 30. Okay, so 30 units, and then to find the area, remember, the area has to find the area. You would need that 12 again, guys, in order to do this. You can't complete this problem without knowing that 12 because 13 is not the height. It does not form a perpendicular with the 5. And so the 5 and the 12 form perpendicular, so that's where your base and your height are. The 5 would be the height, and the 12 could be the base. Multiply those together, cut it in half, or just cut 12 in half to get 6. 6 times 5 is 30. And in this is a rare instance, guys, where the area and the perimeter match up.
Yeah.
So it doesn't happen very often. And that would be 30 units squared.
Right. Yep. Yeah.
Okay?
Yeah. No, that's good.
Okay.
And so looking at area addition, and this is kind of common sense here, but we just want to make sure that we cover this. Sometimes students get confused with this, but area addition postulate says the overall area. So if we're looking at this shape, the overall area in blue here is the sum of the individual areas. So since there's that line kind of through the middle of this shape, we could take that little sliver of a triangle over there, and then the parallelogram, find those two areas separately from each other, and add that together, and that would be the area of the whole thing. And so you just need to be aware of the fact that you can do that. So if we have some weird shape, but as long as we can break it up into shapes that we know how to find the area of, then we just add all those areas together, and that equals the area of the entire shape. And so that's the area addition postulate, is what says that we can do that.
I like to call those composite shapes because it's a couple of things to put together. One other thing, Kevin, if I could just add something. Guys, notice we have this addition postulate come back again. We've seen this 4 times now.
Yeah.
We've had segment addition postulate, angle addition postulate. We have the arc addition postulate, which we didn't really get into.
We'll get there.
We'll get there. But then now we also have the area addition postulate. So these things are kind of redundant. I mean, it's the same idea every time. You can part plus part equals whole, and that's all this is. The area of this piece plus the area of this piece will give you the area of the whole thing. I mean, really, really simple.
Yep. Yep. And so they're going to go through and find the area of this blue shape here. And so if we plug in the area of the outside triangle out there, that little sliver triangle that I talked about first. Now notice where they got their pieces here. First of all, the 1/2 comes from the formula for the area of a triangle. The 5 comes from the fact that the entire base at the bottom is 16, but then the top part of it over there is 11, and it's a parallelogram, and so if you slide that down, that piece marked with the double arrow there to show that it's parallel would be 11. So if you subtract that 11 from the 16, the base of the triangle would be 5. The 10 on the outside is perpendicular to that base, and so that's the shape's height, perpendicular height. And so 1/2 of 5 times 10 is the area of that triangle out there. Then we can take the parallelogram as a separate piece. The parallelogram, the area would be base times height. Now you have to be careful here. The base of that parallelogram is not 16. The base of that parallelogram is only 11. And so if we take the 11 and multiply it by its height again of 10, then that would be the area of the parallelogram. And so if we find those two areas individually and then add them together, that would be the area of the entire thing. Now notice this time we do have units. We have meters here, and so the area is measured in meters squared, or square meters. And so the total here adds up to 135, so it's 135 square meters is the area of that entire shape, broken up by pieces and added together. All right? This is talking about finding the base and height. It's asking you find the base and height of a triangle that has an area of 36 square inches and has a base that is twice as big as its height. Okay? So we're trying to find the base and height of a triangle, and they give us the area. And so we need the area formula. And so we're going to set that up here to where the height is, or I'm sorry, the base is twice that of the height. So the height we could call h, the base we could call 2h to represent 2 times that height. And so here's a diagram that can represent what we're talking about. So if we plug those into the area formula, we would get 36, what they told us the area is, equals 1/2, because that's just part of the formula. The base here is 2h, height is just h, and so we plug those things in, and notice that the 1/2 and the 2 will just cancel each other. And so we're going to end up with 36 is equal to h squared. And so if we take the square root of both sides, h is going to end up being 6. And so if the height is 6, that means the base is twice that, and so the base would be 12. And so that's what they asked us for. Find the base and the height, and so we get 6 for the height, 12 for the base. All right? So kind of a different question there.
Different question, just a matter of when in doubt, draw it out and
Yeah.
plug things
Do a
in. The
diagram.
formula doesn't change.
Yep.
All right, so here we have some more composite shapes. You can look at this as a parallelogram and 2 triangles if you want, or you can look at it as a trapezoid, but we don't know the formula for that yet, so
Haven't gotten
we're not
there
going to
yet.
do it that way. So if you look at this, we know that the top is 18 and that middle piece is 18. So, we're just going to kind of break this up. So if I take that first triangle, I can say that the area of that first triangle is A equals 1/2, 9, because the base of that first triangle is 9, times 13, because the height of that shape is the 13, there's a perpendicular up there, plus, now the area of the parallelogram will just be 18 times 13, okay? And then plus, the base of that triangle would be 11 times the height, which is also 9, and then half of that, so there you are again. Or
Total
13,
13.
excuse me, sorry about that, 13, and then all you got to do, guys, is basically put that into your calculator and
Do the
hit
arithmetic.
enter, or do
all
the arithmetic,
is
and
all it
then
is.
you're good. And the answer is 364 square centimeters or centimeters squared, whichever way you want to look at it. And that's basically it. But you have to be able to visualize that there's a triangle on the left, parallelogram in the middle, and a triangle on the right when you go about doing this question. I mean, there's not much to it. Put 3 areas together and do the arithmetic.
Add 'em up, yeah.
And then finally, we have another one where we have a right triangle on the left there, put together with a rectangle. So pretty easy stuff here, except we don't know the height or the base of that, or we don't know this,
Of that.
the other leg
Right.
of that right triangle on the left. So you have to move that 25 over and then use Pythagorean theorem to figure out that missing piece. So all you have to do here is plug it into Pythagorean theorem. Oh, and you get 19. So c squared, which would be 25 squared minus 15 squared, gets you back down to 225 minus 625 would be 400.
Actually, they were doing the rectangle first.
Oh, they're doing the rectangle first, aren't
Yeah.
they? Yeah, so
Which
there's
is
the area of the
19 times
rectangle.
25.
And then for the triangle, that's also 25 there, so that's going to make that 20, okay? Because 625 minus 225 is 400, square root of 400 is 20. So then we have 20, or 1/2 of 15 times 20. And so then all you got to do is plug it in your calculator or work it out, and you're done. And
Arithmetic again, yeah.
yeah, and you get 625 inches squared
For the entire shape.
for the entire shape.
Add it together.
Yep,
Okay, guys, so it's just a matter of plugging into formulas to find the area.
yep,
Okay? We'll have lots of practice in class.
yep.
We'll see you there.
See you tomorrow.